All right, welcome to the notes for 5-7. These are your inverse trigonometric functions, but this time we're integrating. If you notice, we've gone from 6 to 3. And if you remember the derivatives lesson from yesterday, that's because, right, sine and cosine are only differing by a sign, an SIGN sign, right, a negative. Same thing with tan and cotan and so on. And so the stipulation is that we don't usually assume that it's negative. We would go with just the positive versions. In all of these formulas here, I want to make a note for you guys. A is a constant. And our u is, again, a differentiable function. We'll abbreviate differentiable function of x. So you're looking for patterns with these ones, right? You're going to have the square root of a squared minus u squared. Notice there's a square root. Notice it's a constant minus that function of x. When you notice that, that is our arcsine pattern. And without the square root, right, we have a constant squared plus a function of x squared. That is our arctan pattern. And you want to memorize 1 over a arctan of u over a plus c. And finally, right, this one looks a little different. Square roots again, but notice the key difference. Now you have the variable squared minus the constant squared, plus you have the extra variable on the outside. So here we want to memorize 1 over a arc secant, and we get the absolute value of u over a. You know, for our chapter in the homework, we're going to use all three. On the test, we'll use all three. If you're studying for AP exams, these two are the big ones. Again, if you're moving on to BC, you need all three. You need to be really good with these. On the AB test, they don't show up that often. So bang for your buck, you know, memorize the first two, but I wouldn't worry too much about inverse trig. If you're going for the perfect score, you're going to want to know it. If you're moving on, you absolutely need to know this section. So here's how it works. I started with two that are pretty easy. The first one, right, we want to think about how we would solve these. And I know that it's underneath a section that's called, you know, inverse trig, so obviously we're practicing them. But you want to remember that this is like your last resort, okay? If you're thinking about just finding a problem on an AP test, for example, the first thing you would say is, well, can I just do this with easy stuff, like power rules? If the answer is no, which here it obviously is, you know, then you would say to yourself, well, is there a u substitution? Unfortunately, right, the u substitution would have to be 16 minus x squared, but the du wouldn't help me out, right? There's nothing to help me with that 2x that would be created by a simple u substitution, and I would be stuck, right? Then you might look for things like logarithms, exponentials. Obviously, it's not an exponential. The item of last resort, I cannot find a way to integrate this thing at all. Could it be an inverse trig pattern? Okay, so it's sort of the last option for you. And this one, if we're thinking about that, does match, right? I have a square root and I have a constant minus a function of x. So here we want to think of it as our a being equal to 4 and our u is just the x. Given that u is simply x, and it's just a matter of naming, then I can use this formula right away, and I can just plop in the right things in the right places. So here, my answer would be sine inverse, or arcsine, doesn't matter, u over a, so x over 4, and plus c. And that would be the end of it. I'd be finished. So that's our sort of best case scenario. This one's going to be a little bit trickier, right? You would normally run through, look at this problem and say to yourself, well, you know, is there an easy way to solve this problem? You can't split a denominator, right? So power rule is not going to help me here. U substitution, I would run into trouble because my du would involve an 18x, and I don't have a way to get out of that. But if I think about it, this one matches my arctan formula. I have a constant and I have a variable squared. So I want to think about, well, if a squared is 2, then my a is the root of 2. And this, right, would represent my u squared. So that means that u is 3x. Now notice the difference between these two. Right here I had a simple substitution, u equals x. If I had continued along the lines of our u substitution, I would have just noticed that everything was the same. It was a matter of lettering. On this one, I want to carry through and notice that I'm going to have to complete the substitution all the way through, because that factor of 3 would sort of alter the equation. So here, I'm going to rewrite it so that it looks exactly like this one. I'm going to think of this as 1/3 times the integral of du, right? I swapped out my dx for 1/3 du. And then on the underneath, right, I have the root of 2 squared, and I have u squared. Now it matches that pattern perfectly. So this one is not quite as nice as maybe our first example was. But from there, it is just a simple application of the formula, right? It says that I'm going to take 1/a. So in this case, 1/√2. I don't want to forget the 1/3. I almost did. And then I would have the arctan, or maybe you wrote tan inverse, doesn't matter, and u/a. Let's not write u, because we're just going to have to recopy anyway. So 3x/√2 plus c. And really, we can leave it just like that. Please don't worry about rationalizing denominators. The AP test won't either, and I won't for the test. So those are two pretty straightforward examples, right? Example B here was a little bit harder than example A. But overall, they were applications of those formulas that you want to memorize. On the back side, we'll get into some that are a bit more tricky.